We're going to talk about troubleshooting in this video. We've certainly all done a lot of troubleshooting since you've started this class. We troubleshoot our own work all the time. We're going to expand on that a little bit because you're not always going to be troubleshooting your own work. You're not always going to be troubleshooting something that is a problem that you caused just minutes before when you wrote it. You know, sometimes you're going to be troubleshooting a bug that pops up in your software maybe weeks, months, or even years after you wrote it. You may not even remember what you wrote. You may be troubleshooting code that somebody else wrote. So it's important to have a good plan of attack of the steps you need to take when you're troubleshooting. So we're going to divide our troubleshooting steps up into 6 steps. Okay, so we're going to talk about these. We'll list them here to begin with, and then we'll go through and talk about each one briefly. So your first step is always to investigate your symptoms. Make sure you have a clear understanding of what is happening. Okay. Then you attempt to identify the problem to make sure you understand where in your code the problem exists or where in the system the problem exists. Okay. Then you come up with possible solutions. You design solutions that will fix the actual problem that you have. Once you've designed some solutions, you pick the best ones, and then you test. It's important to test your solutions to make sure they fix the problem you have without breaking something else. Step 5 is to implement the solution. That means actually get it out to the users that need the solution in place. And then step 6 is to document the solution. So let's go through and talk about these steps individually. Okay. So investigating symptoms. Okay. What does it mean to investigate symptoms? We have to determine what is happening. So sometimes users will call in and say, hey, I've got a problem with this. And we think we understand what they mean. And we spend a lot of time trying to duplicate their trouble, trying to simulate the same problem that they're having so that we have something to work on. And in reality, we didn't really take enough time to listen to them and to understand what was really happening in the system. So it's important to talk to those stakeholders and make sure you have a very clear understanding of what the problem is that they're having. Try to watch their screen if you can. Have them step you through the process. Try to duplicate the symptoms on your own computer using the exact version of the software that they're using. You need to clarify anything you don't understand. So this first step, if you don't have this, it's going to make it very hard to go on to the next step, which is identifying the problem. If you don't really understand what the problem is, what the symptoms are, it's hard to find out where the problem is. Okay, so how do you identify a problem? We identify problems in our own software all the time as we're writing it, but how do you identify it when it's not code that you just wrote? You're not really familiar with it. You do things like looking for patterns. Okay, there's 3 different ways I can cause this problem. What do those 3 ways have in common? Or there's 2 different ways. Or when I do something this way, it works, and some other way it doesn't work. What's the patterns? What are those similarities and differences between when it works and when it doesn't work? Because if we really look for those things, it will help us understand it. We can use our debugging tools. This is one that we probably do the most because most of the troubleshooting we do right now involves fixing code that we're writing at the time, right? So we understand where the problem is, and for the most part, it's in this section of code because it's the section I just wrote. So that's when we use our debugging tools to step through. And remember the secret to debugging that I repeat over and over. You have to understand what the code is supposed to do so that you know what to expect. And when you get a result that is not what you expected, you know where the problem is. So know what to expect and how it's supposed to work. Find out where that breaks down. And then Sometimes it comes down to garbage in, garbage out. Sometimes you see that abbreviated GIGO, right? Garbage in, garbage out. If you put garbage into a system, we've been writing files lately, so reading and writing files. If you're reading a file that doesn't have good data in it, there's no way you're going to get correct data out, right? So you got to make sure that the things coming into your system are good. Otherwise, you'll never get the right values out. So once you figure out where the problem lies, you need to figure out how you're going to fix it. How are you going to fix it? Come up with a list of things to try that might fix the problem. Do you need to change a formula? Do you need to change the way a loop works? Is the loop counting from 1 instead of 0? Does it need to count up to the length, or is the length minus 1? Well, you know, how did we screw that up? What happened? List all the things that we could try to do to fix it, and then narrow that list down. We rank the list. Which one of those solutions do you think will be the best? It may not be the best, but which one do you think will be the best to start with? Okay. And then you form a plan of attack. Okay. We're going to try this solution to see if it works. Okay. And then we move on to the next step, which is testing the solution. Now, here's a very important part of that. Use a test environment. So if you're working on a code that's on a system that's in production, meaning users are actually using it at the time, you don't go in and test your fix on a live system, because your fix may end up breaking it worse than it was to begin with. Okay, so you use a test environment. You set up a test computer with the software on it, and you try to test it offline where it won't hurt any live data or anybody else that's using the software at the time. You try the best solution of all those ones you made in the last step. You try that solution first. Okay, and if that doesn't work, you try another solution. So that's why it's important to have more than one possibility. You try the ones until they work. But here's a key to that. When you try one solution, and I see students that do this all the time, their code doesn't work correctly, and they think, oh, here's something I could try, and you go try it, and it doesn't fix your problem, but you don't change the code back to what it was. Okay. If you try something different and it doesn't fix it, don't leave an unsuccessful solution in place, because when you finally do find the problem, that thing that you might have changed that didn't fix the problem could end up being a new problem that you've introduced. Okay? So make sure when you try different solutions, try a solution. If it doesn't work, roll back. Okay? Try another solution. If that doesn't work, roll back. And then try the third solution. If that doesn't work, roll back until you find the solution that does work. But what you don't want to do is change your code in 5 or 10 places, and then at some point, maybe you did fix the problem, but you broke it in some other way, so you never really know, because you left all these unsuccessful solutions in place. All right, so be careful about that. Test systems offline in test environments. That's easy for us in class because everything we're doing is a test environment, right? We're learning to write code. Finally, you implement the solution. Once you figure out which solution fixes the problem, you have to roll it out. You have to come up with a plan. Okay, now we know how to fix everybody's system. How do we get it out to our users? Has our software got some kind of automatic updater built into it? Do I have to communicate with the user somehow? Do I have to send out a bug repair through some system, or do they need to download it off of our website? How are we going to get that solution out to the people that need it? You need to communicate with users. You don't want to just automatically send out a bug fix without telling them, hey, tonight there's going to be an automatic bug fix applied to your system, because they might not understand why their system doesn't work the next day if your bug fix broke something else, right? So make sure you communicate with them. Hey, we fixed this problem. You've probably got that even with games. Hey, there was an update to your game and it fixed these issues. Make the changes, verify success. So don't just send out the fix without actually testing it once it's installed on the user system. Make sure it fixes the problem. You know it fixed the problem on your test computer, but once you roll it out to the user who needs the fix, you should verify that it succeeded in fixing it on their system as well. Don't assume that it will, and you know what they say about assume. If you don't know what they say about assume, take a little time to look at how that's spelled and you'll figure it out. And then the last step, and this is a very important step, document the solution. Hey, we had users that had this problem on these computers when they did this certain thing. Okay, and this is the fix I came up with that fixes it for them. You write it down and document it so that if you're in a company with more than one person that might be troubleshooting, the next person calls in and say, hey, I have this problem. You don't want them to spend hours finding a solution that you've already found. So a lot of companies will have some kind of bug tracking software where people can type in their symptoms and you can look it up and say, oh, somebody else had that problem and here's what they did. They updated this table in the database, or they changed this setting in their properties, or whatever it was that fixed the problem. You document it so that other people know about it, but also right here, step 2, so you will know. I have a little folder that I keep just for the classroom configuration that I use here at the school for my classroom. They'll do the commands that I run to set up computers every year so that everybody has the same environments. I know what they are, but I document them because if I can't remember a year from now what it was, I can look it up. Hey, what was that command I ran? Oh, I had that problem before, and here's my little list of fixes that I keep track of for myself. Okay. A company will keep track of it probably in some kind of system that we talked about, but even for your little projects, keep track of your bugs and jot down things so that you can remember if you have to look at your code a week, a month, or a year later. Okay. It will help you solve future issues much more quickly. Okay, so that's it. That's the 7 steps. Let's go back to this slide. Make sure you know and understand these. Again, in class, you're fixing bugs that you've introduced yourself, so you may not do all the steps every time. But in a formal system, if you're working at the help desk or whatever, these are the steps that you need to take to help fix software problems. Investigate your symptoms, identify the problem, then design the solution, test it in a test environment, and figure out how you're going to get out to the users and implement the solution, and then make sure you document the steps that you took.